Hi everyone, Assalamualaikum warahmatullahi wabarakatuh. Welcome back to CHM421, which is analytical chemistry. In this video, we continue our lecture on the topic 2, apparatus and techniques. Uh, Focus on volumetric glassware. On the previous video, we discussed on the analytical balance. It's the equipment to measure a mass or weight the sample of the chemical. So for this volumetric glassware, it will be focused on measuring the volume. For every accurate volumetric analysis, you need to calibrate the volumetric glassware. All the volumetric glassware are allowed to tolerance in manufacture. For example, in 100 ml of volumetric flask is manufactured to be tolerance of plus minus 0.08 milliliter. And since the liquid in the glass can be expand or it can be contract as the temperature rises and falls. Therefore, the tolerance applied, the temperature is indicated on the flask, usually 20 degrees C. So, measuring volume, the SI unit is liter, but you can present the volume in different unit like dm cube or milliliter. So this is the conversion from one unit to another unit. If we have one diameter cube, it equivalent to 1 liter. It also equivalent to 1000 milliliter in 1000 centimeter cube. Uh, the glass that used in manufactured the volumetric glassware, it can be origin from borosilicate, it can be from soda lime, or it can be low acetylenic acid, boron free in high silica. For example, the glass, the way that we use in the kitchen, like the Pyrex or Corex, normally it manufactured using borosilicate. The volumetric flask, stirring roots or disposal pipette, it manufactured using soda lime. So you can read this table to know various ingredient for different glassware and that in their particular properties. So seems when we have the error in analytical balance, we have buoyancy correction. Also, seems goes to the volumetric glassware. It also have error, but we not focus on the correction, the volume of the volumetric flask. We more focus on the parallax error. Parallax error meaning that the liquid, when it confined in a narrow tube, it can be exhibit marked curvature at the top of surface, which is we call it meniscus. Reading appears smaller when read from above or appear larger when we read the reading from below the meniscus. So we should apply a correct way to read the reading on the volumetric glassware. The correct reading should be obtained only when the meniscus is seen at the eye level. So this one is incorrect because we see from the above of the meniscus. This one also incorrect because we read the reading from below of the meniscus. So this one is the correct one. We read the meniscus on the eye level. So, volumetric glassware can be divided into two groups, volumetric or non-volumetric. The volumetric glassware can be labeled as TD, to deliver, or TC, to contain. Non-volumetric is only to contain. So, as I mentioned just now, volumetric glassware can be both. It can be to contain and or it can be to deliver. So the to contain normally we have volumetric flask. So for preparation of standard or sample solution, or graduated cylinder also to contain, to measure the content of the solution using volumetric flask, or to measure the volume of solution using graduated cylinder. The graduated cylinder is for rapid measurement of liquid volume, but it's less accurate. To deliver is to deliver the volume of solution. So the usual glassware that we use to delivering solvent from one apparatus to another apparatus, pipette. So we can have several type of pipette like this, or we also can have a bulk pipette, and also we can have micro pipette. So the pipette normally we use for transferring the liquid. This is why we call it to deliver. Same goes to the burette. Normally it used for titration, accurate in dispensing a liquid of solution. So to contain is to measure the volume using volumetric flask or graduated cylinder. To deliver is to deliver accurate amount of volume either using a pipette or burette. Non-volumetric is only to contain. Normally we use a beaker, but beaker is only can be used for transferring liquid to another container. Uh, this is non-volumetric glassware. Beaker we can use to measure the volume of the solution, but this one is incorrect. But normally we use the beaker to store the solution or to transfer the solution to another container. As I mentioned just now, volumetric glassware, it can be labeled as TD, to deliver, or TC, to contain. Volumetric glassware, which is volumetric flask, uh, graduated cylinder, pipette, and burette. It can be TD or TC. TD meaning that to deliver the specified volume at the calibration temperature. As I mentioned, pipette and burette. Also, it can be TC with the frosted ring near the top to contain the specific volume. For example, we have volumetric flask as well as the graduated cylinder. Volumetric glassware. We have to calibrate the volumetric glassware for every accurate volumetric analysis. So the all the volumetric glassware are allowed to tolerance in manufactures at the specific temperature. So, for example, this is a pipette, 25 milliliter pipette. So the calibration mark indicate the 25 volumes of the pipette. Also, we can have burette uh, as well as the volumetric flask. The volumetric flask, the calibration marks indicate the calibration marks here indicates the 250 milliliter volume. This is the clear pictures of this slide. I make it, I enlarge the picture so you can see it nicely. The calibration mark for the pipette and also the calibration mark for the volumetric flask. So every all the volumetric glassware are tolerance. So if the volume of the volumetric glass exceed the tolerance, meaning that the glassware need to be calibrated. So how to calibrate the volumetric glassware? Why we need to check the pipette, burette, and volumetric glass regularly? Because we want to avoid the unnecessary inaccuracy and imprecision on scientific data. This is why we always do the checking. If the glassware is not accurate, we have to do the calibration. So there are several techniques for calibration of glassware: direct calibration, indirect calibration, or relative calibration. So direct calibration is the volume of water delivered by a burette or pipette or contained in volumetric flask is obtained directly from the weight of the water and its density. Indirect, we compare the mass of water a volumetric glassware contains or deliver at particular temperature with another vessel which have been calibrated directly. The volumes are directly related to the mass of water. This method is more convenient if we have many pieces of glassware need to be calibrated. So relative calibration, volumetrics relationship between two items of glassware without knowing the absolute volume of either. This situation arises, for example, in taking a liquid portion of solution. So we have three techniques: direct calibration, indirect calibration, and also relative calibration. So this is the example how to calibrate 50 milliliter of volumetric pipette. So before we do the calibration, we ensure the pipette that we desire to calibrate is clean. If a small droplet of water hit higher in the inner surface of the pipette after delivering the ionized water, meaning that the pipette is dirty. So you must clean before proceeding further. Determine the mass of the empty stopper receiver to the nearest milligrams. We transfer the 50 ml volume from the pipette into the stopper container. We weigh the stopper receiver in its content, meaning that it contains water, and we calculate the mass of water delivered by different. From the delivered mass of water, we calculate the volume of delivered using density table. We repeat the calibration 3 times at least, and then we average or we mean value the mean volume delivered, and then we obtain the standard deviation. Uh, on top of calibration the volumetric flask, we also should know about how to marking and labeling each volumetric glassware. Uh, Marking and labeling each vessel with that holding the sample or reagent should be properly labeled, so the content can be positively identified. We can use a sticker or label, or we can use a special marking ink where necessary. So now we will focus more on pipette. As I mentioned just now, pipette normally used to transfer the accurate known volume uh, from one container to another. It is sometimes used to deliver a certain fraction or certain portion of solution. We call it or liquid. Uh, This is why pipette can be calibrated STD to deliver, or it can be to contain. So this is several example of pipette. Pipette. Uh, Hold on. Okay, this is the same slide as previous. Pipette is used to transfer a particular volume of solution. It transfer the accurate known of volume from one container to another, or it can be deliver a certain portion or a liquid of the solution. A liquid meaning that a sample of solution taking from a larger sample volume. If the pipette label is TC to contain, the small remaining volume should be second or blown out in order to obtain a correct amount of material or sample. If its marking is TD to deliver, a certain small volume remaining on the tip should not be shaken or blown out. So in delivering, the pipette should be held vertically and the tip is touched on the side of the vessel to allow smooth delivery without splashing and a proper volume lift in the tip. So a few types of pipette. First, volumetric or transfer pipette. Sometimes we call it bulb pipette because they have a bulb in the middle. So this bulb pipette is labeled as PD to deliver. The volumetric pipette is used for accurate measurement only one volume. So, for example, this one is 25 ml, so it can be measured only 25 ml of volume. So the pipette can be ranging in volume. We can have 5 milliliter up to 100 milliliter with respective tolerance. We also can have graduated pipette. Normally is the TC to content. So this kind of pipette, graduated pipette, is TC. Uh, they have marked at different volume interval. They have marking. That's why we use it for TC to content. However, this graduated pipette is not accurate as the bulb pipette. It can have a larger error effect on the total volume. The techniques of using the pipette is usual. The pipette should be clean. We clean the pipette using detergent and water, and then we rinse the pipette thoroughly. First, using the tap water, follow up by the distilled water, and then we rinse again twice with the small volume of the solution to be transferred. And then by using the filler, normally the rubber pipette bulb or the pipette pump, we, we fill the pipette above the calibration mark. We hold the pipette vertically, the tips against the beaker. Uh, we use the tissue paper to remove drops outside of the pipette near the tips. So we mark at eye level, allow the solution to drain slowly until the bottom of the meniscus. If the bottom of the meniscus falls below the calibration, we start again and refilling using a safety filler. Allow the content to drain out into the conical flask freely. We hold the pipette tips against the flask wall to avoid splashing. After the pipette appears to have drained, allow 5 seconds or 10 seconds for further drainage. We do not force the content out of the pipette. Don't blow it out using your mouth. We wash down the inside of the pipette using the distilled water. No solution should be pipette by using the mouth. So this one also seems like the previous one, a proper technique for using pipette. You can read up. You can compare with the previous slide, and then you can make a summary how to use the pipette properly. So this is a proper technique to dispense the solution using the pipette. Also, you can read up on this slide and then make your own summary. Okay, hold on. Direction to use, we clean the pipette, as I mentioned, using the detergent and then using the tap water 3 times at least. We fill the pipette using the distilled water, and then we rotate to cover the entire interior surface. I repeat several times. We draw the solution, we rinse it at least once or twice using the solution to be used. And then we use the buff or the fill the bulb to fill the pipette above the calibration mark. Replace the bulb with the forefinger. Press tightly to avoid the volume to make the correct volume. Check the air bubble. Wipe the exterior pipette using the tissue paper. Without the pipette slightly or rotate likely be partially releasing the forefinger. Level the solution will drop in and its meniscus touch the marks. Press forefinger firmly back in the mouth of the pipette. Drain the solution freely into receiving nozzle. Avoid the splashing and the loss of sample. Place the pipette tips into receiving nozzle. Touch the tip to inner wall. Liquid will be further drain out but never blow the still remaining liquid. Clean the pipette using the distilled water immediately after use. This is the technique how to disperse the solution. Draw a small amount of liquid in with the interior surface of the glass by tilting and rotating the pipette. Remove the solution of the pipette. Draw a solution to slightly above the mark. Quickly replace the buff with forefinger to arrest flow of solution. Wipe exterior with less tissue to remove whatever adhering liquid. Rotate the pipette to adjust the volume to coincide with each mark on the pipette. Allow the liquid to flow into receiving vessel until no more liquid can be removed by the gravity. Finally, tug the flask slightly and touch the tip of pipette to the inside of flask. Note small amount of liquid will be remain in the pipette. Do not remove or blow this liquid. For the TC, because TC. The pipette is calibrated to deliver in rated volume with the still liquid remains in the tip. So now we're moving on the burette. Burette also to deliver is the volumetric flask to deliver TD. It used for accurate delivery of variable amount of solution. So the scientist or the analyst can be delivered any volume up to the maximum capacity. For example, during the titration. As I mentioned, burette normally we use during the titration where the standard solution is added to the sample solution until the end point reach. We can have various volume of burette from 0 to 50 milliliter. So how to use the burette correctly? As usual, the burette have to be cleaned using detergent and water, and then rinse it with the distilled water. Next, rinse the burette twice using a small portion of the solution to be transferred. And then we're using a small funnel to fill the burette with the solution to be transferred. And then we remove the glass funnel or the plastic funnel. Uh, Open the tap to run out the bubble in the burette tip. We can open this one to we can open the glass, open the burette this valve to remove the bubble on this burette tip, or we can knock it lightly also to remove the bubble. So to allow the meniscus to fall to the level of 0 and 5 milliliter calibration. And then we touch the beaker against the tip to remove any drops that not fallen off. Of course, the burette have to be held vertically and the meniscus at the eye level. So we can record the initial reading. So this is the meniscus level. So initial reading before we start the titration. Uh, Read the reading from the burette on the meniscus level 20.1. In this case is 20.1. Okay, this is a complete set of titration. We have restored stand. We have burette, it containing the standard solution, and we have conical flask containing with the sample with indicator. So this is how to read the burette. Make sure your eye on the meniscus, not from the above of the not not from above or not from below of the meniscus. So for example, this one is 4.8 milliliter and this one is 5 milliliter of volume of solution. We transfer the solution from the burette into the conical flask until the end point is reached. By practice, you should know what is the best to turning tap, either using your left hand or right hand. It's depending on you. Uh, you can use whatever hand that you convenient, right hand or left hand to swirl the conical flask, meaning that during do the titration, you have to control the turning the tap and also swirl the conical flask. Either using left hand or right hand is depending very much depending on your convenience. Before start the titration, make sure you record. Sorry, before start the titration, just now make sure you record the initial reading, and then after you open turning tab open, uh, and then you can record the final reading after the endpoint reach. The difference between the initial and final reading is the tie 3. Tie 3 is the volume of the liquid delivered from the burette. When you do titration, you can try and error. You can start with the rough titration in order to estimate the volume uh, of the standard solution required to reach the end point of the sample. So this is why the titration should be conducted several times, and then you can average the titrate the volume of liquid delivered from the burette to know the volume of accurate titration. Okay, so far we done pipette and burette. Now we do the volumetric flask. If you still remember, volumetric flask label is TC to content. It measured. It used to measure the volume of solution. Normally, volumetric flask is used in the diluting of sample to the certain volume. Uh, Seems with other uh, volumetric glassware, this volumetric flask also can have a ranging of volume from 100 ml up to 2 liter. So this volumetric flask, as I mentioned just now, is designed DC to contain. So it's to measure the volume. Initially, a small amount of diluent, normally distilled water, is added into the empty volumetric flask, and then the region. Make sure the region's chemical should never be added directly to the dry volumetric flask, because the glass is highly absorbent to the concentrated substance. This is why we weight the empty flask using the diluent. And then the desired chemical reagent, either solid or liquid, can be added into the flask. The dilution solvent can be added to fill two-thirds of the volumetric flask, and then we swirl the flask. After that, we can further add it to the neck of the flask. Finally, very careful, the final diluent is added to the meniscus, just by dropwise manner. The solution is finally thoroughly mixed either by inverting the flask or swirl and shake it vigorously within 10 to 30 seconds. We can turn right side up, or we can repeat this inversion, shaking or swirling at least 10 times to make sure all the mixture mix homogeneously. So this one slide discuss on preparing a standard solution. We want When we want to prepare a standard solution, we weigh the exact mass of the solid, and then we add enough water to dissolve the solid chemical. Alternatively, we transfer solid into flask to avoid error on transferring. Transfer quantitatively into volumetric flask to contain, and then add water up to the mark. Use a dropper to achieve this in order to avoid the overshoot of the volume. We put up a stopper and we invert the flask many times to give homogeneous solution. Other type of glassware, uh, we can have filter funnel. We can have conical flask or linear flask. We can have separating funnel, wash glass, evaporating dish, test tube. This one is desiccator. We can have flat bottom flask. So, how to clean the glassware, either volumetric glassware or non-volumetric glassware? We use warm detergent. We can use concentrated acid. We can use dichromate sulfuric acid, aqua regia, and also ultrasonic cleaning technique. So, clean the glassware is very important for accurate and precise volumetric application. So we have to clean all the glassware before use. When we want to use a warm detergent, normally warm detergent, we soaking it in warm detergent solution is sufficient enough to remove the grease or the dirt that are responsible for water breaking. If the detergent is ineffective, and then we can use a cleaning solution. The whatever flums it higher inside the flask or inside the bottle, we can be removed using dilute nitric acid. and then followed by multiple rinse with distilled water. Uh, this is another cleaning solution, concentrated acid. We can have concentrated HCl, hydrochloric acid, that can be dissolved mini metal or metal oxide. Hot concentrated nitric acid to dissolve most of the metal. Hot concentrated sulfuric acid to dissolve many substance. Uh, Organic material can be charred or can be oxidized. This is another cleaning solution, dichromate sulfuric acid. So when you want to use the dichromic sulfuric acid, you should be handle it with extremely care. Seems close to this concentrated acid. Handle with careful. Which you should use PPE, wear eye protection, and also avoid any contact with the clothing and skin. So this is the preparation, how to prepare the dichromate sulfuric acid. We dissolve sodium dichromate, or we can have also use potassium dichromate in water, and then we add with concentrated sulfuric acid in order to get the dichromic sulfuric acid. After the glassware has been cleaned with the detergent, rinse carefully. We just only use a small quantity of the chromate solution into the glassware, allowing it flow down all parts of the glassware surface. And then we rinse with distilled water well. The cleaning solution, dichromate sulfuric acid, can be reused until it acquires the green color of chromium ion. Once green color appeared, uh, this cleaning solution should be discarded. However, you are not allowed to dispose this chromate waste solution into the community waste water system because it contains of heavy metal, which is chromium. Okay, another cleaning solution is aqua regia. Also, it should be handled with extremely care. Use the eye protection and avoid the contact with clothing or skin. How to prepare the aqua regia? The acid hydrochloric plus with acid nitric acid. Uh, this aqua regia, even though it's a very powerful cleaning solution, however, it is extremely dangerous and corrosive. So normally, people using the aqua regia in the film code. Okay, another technique for cleaning the glassware using ultrasonic cleaning. Ultrasonic glass cleaner are very good for cleaning a pipette, uh, uh, such as auto pipette tips or the burette. We soak the glassware in the warm detergent solution, and then we apply the acoustic energy of frequency, at least 40 kilohertz. The ultrasonic vibration will dislodge the dirt and grease quickly from the glass surface in a very short of time, less than 5 to 10 minutes. So this is the example of ultrasonic cleaning equipment. All right. So that's all for this video. We discussed about volumetric glassware, volumetric glassware, and non-volumetric glassware. Uh, Volumetric flask, big graduated cylinder, pipette, and also burette. We learn how to use it properly, and at the last of this video, we covered a little bit how to clean the glassware using several technique and for several cleaning solution. All right, that's all for this video. See you again on the next video on water for laboratory use.